Hey, David here. We are live at the Automotive Testing Expo. Just got here. Conference started yesterday. I usually go on the first day, but because of the Sukkah holiday, I wasn't able to make it. Hopefully, I have good reception. Unlike the Battery Expo, that was just overpacked. Because it's a new business, more money to be made, more interesting automotive testing. Although possibly a bigger, more prominent conference, has less traction, less thoroughfare. So I've been going to this for quite a few years, and anyone who listens to my rambles regularly knows that my friend chess player, Mr. Kaufman, we'll say hello to this man 1 second, and Andrew.
How's it going?
Hey, guy. Good to see you.
Long time.
So this is a testing expo, testing equipment for automobiles. So the automotive industry, obviously, starting out here in Detroit largely, has a conference that just includes testing equipment. And I'm walking through right now the first time. I'm going to try to go for the whole theater. Hopefully the reception here is all right. The last time I got blocked, the battery, there's not enough bandwidth, but I hope there's enough bandwidth for me to have good reception here. So I'm going to try to start from one of these corners and go all the way through. I guess you get free coffee. I might even grab a free coffee. Let me make a free coffee while I ramble a little bit and try to give some thoughts. So people who know the history of automotive engineering, you had Fordism, the Ford manufacturing process, where they streamlined production, and the River Rouge plant, which famously had all of the various aspects of the process of making a car under one roof. And at the time, that was very economical and led to vast profits and the growth of Ford. Although at this point, that's not the current status of how cars are made. It's been the logistics process is now worldwide, and you have all these various components and parts that are made all over the world. So an automobile requires countless parts. Tens of thousands of components go into automobiles from and really all of the latest technology is most likely to be incorporated into the automobile of any of the various type factors and sectors of manufacture or science, technology in general. The automobile is the biggest segment of all of manufacture and the most likely to incorporate any new form of technology, materials, IT, computer, and all these various things, because your car is largely a computer today, the electronics, and gas emissions, energy, and these various factors all get incorporated into the automobile. So this conference is specifically on testing of the automobile, and they'll have some suppliers and just various companies that come to a lot of these, but this conference is specifically designed on companies that test parts for the automobile. So here's just suppliers. You get things like bumpers and seat cushions and materials, and historically they had like the final assembly plants, and then they have your various tiers of like tier 1, tier 2, and tier 3 suppliers. Tier 3 suppliers could be like tiny components that you might not even realize go into an automobile, versus like tier 2 might be things like this that obviously go into an automobile. But are made by various companies, to tier one, where you have whole parts of automobiles that are ready to be put into final assembly, and then you also have the various companies of manufacturing lines. So anyone's been into some of these, seen my rambles in the past, or goes to these regularly, is familiar with that. So it's just saying that the whole automotive assembly manufacturing process is largely spread out over the whole world. So here you have next year Adhesive and Bonding Expo. That's going to be here, I guess, part of the Foam Expo. So I streamed from the Foam Expo last year. Pretty interesting. So you got the robotics displays and polishing parts, various things that microchips. So starting in the corner here, just getting a feel for what's going on. So as mentioning, this conference is designed around testing equipment for the automobile, because when the automobile comes out, a lot of these companies, there's not too many companies that make an automobile. It's expensive, and so you have was Automotive Interior Expos. Is that next week here? Yeah, so just I might look at this later, walk around, but so just interiors to the cars. So there's a whole expo just on the materials that go on the interior. So here you have companies that make various seats and sewing equipment. I've shown some of these in the past, the sewing machines, special for industrial sewing, and they even have the computerized sewing machines where you have designs you could program into designs in the computer, and then that computer could sew out the design similar to CNC machines or wood cutting machines that are through all the fields. So car comes out, there's insurance liabilities, it needs to work, it needs to be safe. So they go to extreme measures to test these automobiles, to make sure they're comfortable, to make sure that they're working right, to make sure that they are going to be durable, have a long life, and stability. So you see some interesting seats here. So you have companies that specialize in automotive testing, and that could be for various sensors, that could be for various equipment, durability, and you'll see also that they actually have huge plants that test things for like weather, stress, strain, vibration, and so there's various methods. So if you want to look how a car holds up to how an automobile holds up to extreme cold, you could either build a facility in a very cold place, or you could artificially generate cold weather and warm weather. So they have various facilities that have these huge chambers, size of buildings that could fit cars or multiple cars, and will either be very cool or very heavy, or vibrations, and you get crash test dummies, and actually simulating crashes, and then you have actual tracks in various areas. Some places are very cold. For example, to test how the car goes up against cold weather. So here's an example of one of these cutting machines. Well, they probably do. I mean, anything. Jim's asking me about salt-resistant panels. So there's a cost trade-off with material science. So just showing here, there's one of these sewing machines where you can program in the design, and they'll sew and cut. And I've shown these in past years. I might come back and grab some of the books. So here you have, so I started on the one side, and this is more like materials, more automotive. So I haven't got really to the test equipment. So these places are kind of like designing panels and bumpers and displays, industrial solutions. So I mean, if you're looking at solving the problem for salt, so obviously all material like eventually crumbles. That's, entropy, church of entropy. There's a law of entropy that everything is going to go towards disorder at some point, and all you could do is delay that disorder. You can't make something because of the law of entropy. You can't make something that is just never going to default, never going to have problems. So you have to look at a cost benefit analysis. How much does it cost to produce the equipment, the material, first the level of restraint in terms of cost. So here's the operating machine, sewing, cutting machine. I'm going to say a blessing. Test you more equipment here. So these machines might cost hundreds of thousands or millions of dollars. Here's just generic sewing machines. So pretty cool stuff. Get a little bit of this out here. See some of these displays. You have manufacturing solutions companies to make fixtures. So sometimes in the automotive process, the companies will actually just bid out the parts that they need in a number. So if in order to make the part of the automobile, because you don't really have a company that makes complete automobiles. There's big companies like Bosch that might make enough equipment that would completely go in an automobile. But generally no company makes everything of the automobile process. They rely on other companies, and they might need like a widget, any of these like random widgets. So you could openly bid that out in a manufacturing process, say this is what I want, and then how many pieces they want, and bid it out. And usually there's companies that specialize in it: fiber material, glass fiber, felt, more seat cushions. So you might have companies that specialize in making a certain part of a car, and actually some of those companies might supply to all of the main suppliers. So it's like you don't have necessarily like Ford or General Motors that has its own company that makes seat cushions, mirrors, little widgets that go in a car. However, you have main suppliers that became big and might supply to all of the companies available, and there's always competition. So you could have a company, as I mentioned at the battery show, that start with just one small fragment of the industry, just makes one piece, and make a business. As the automotive is the single biggest sector of manufacture. So if you could supply one piece that's useful for automotive, you could have a huge business. So you could be a millionaire selling millions of some random widget. But most of the companies that do that will slowly move into a sector in line. So here you got like wiring and metals and various samples of all the type materials that a company might make, and products on display. So it's a huge design. There you got Dassault Systems. Go there in a second. Our nice company. So just walking around, trying to keep my head straight and kind of ramble on the direction of technology, the purpose of this conference. So as I said, so companies will specialize in one thing, and then once they get good in a certain field, they'll probably expand into more and more similar items, and then based on that expansion into similar items, they might go based on processes. Like, okay, they're making mirrors, like rear view mirrors, and they could do various mirrors, but once they have the components to do that, they might move into dashboards or something. So here's automotive simulated testing. I've shown these in the past. I've sat in one of these before. So you have computer simulated testing. Here's very high process cameras. These are pretty cool. I've shown these in the past. High-speed cameras that could take millions of pictures per millions of frames per second for testing. So we're going to get later into some of the actual sensors and testing where they will set the cars up to. So I just finished I guess the section over there, the yellow section people are watching was kind of like the interiors part. So now we're in the blue section, which is more the automotive testing itself. And so now we'll have sensors. Here is mostly the computer simulated equipment. I've shown these in the past. They have different sensors that will do sound or heat or vibration, and you could put any of these sensors into a car, and you could basically reduce an automobile to a series of differential equations and show exactly how much strain, what will happen that will cause a car to give out, and know on a level, this is the material, this is the amount of strain or stress it could handle, and past that level it's likely to buckle, or regular use levels, city driving, highway driving, certain speeds, wear and tear, like you're mentioning, weather concerns, various things that your expected life average of a car, and the expected amount of money that will go into maintaining a car. So here's a demonstration for driverless cars, sensors for different things. We'll see later. Some how the companies that come to these conferences choose to display their products. Sometimes they put a whole bunch of stuff like D-Space, big company. I've been coming to these in the past. They got all types of sensors, and they produce very good reading material about the future direction of technology. Hey, God bless. So you got Siemens, electrical company. Hey, guys. So most of the major companies are represented here. Some in bigger order. Some of them you would never heard of. They're related to a field, but in sensing. And presumably as I move on, we're going to actually see some automobiles, and we'll see a whole series of these tested. So here are kind of like these electronic measuring that you have the sensors, and then you feed them into the computer, and the computer will measure all this type of data and try to I'm going to come back around and collect reading material after I do my ramble, but the computer will collect the data that is fed into it, and it'll be a storage, and you could graphic or do whatever you want. But if if you have a automobile or a part of an automobile, and you're testing it, and you're just running it for hours under various conditions, and you have a sensor connected, and those sensors are connected into these feeding into these electronic servers, and then they record everything that goes into it, and then that data is made available to the engineers for the test. So how strong is the material, how resistant is it, under what conditions causes the material to strain quicker, and various things. That's we're going to see more. So I finished, I started in the slow corner, because I figured it'd take viewers a while to get in. And so now you'll see some more, technology displays. So here's, an example of just a model toy car and various sensors on the car, and that would be fed into a computer that would be measuring it, and the various transducers and stress data logging. I didn't have too much time to prepare for this because of the holiday. I played a lot of chess. I just wanted to keep my mind sharp, just temperature here. So I didn't have too much time to... Hey, God bless. Good to see you. Hey, good to see you, my friend. Shalom. Excellent. Thank God.
Yes, David.
Yep. Good to see you every year.
Yeah, you're always coming by every year.
Yeah, I started live streaming.
Yeah.
So I got Yep. Yep. Awesome.
Headed to Israel soon.
Oh yeah. Enjoy.
Yeah.
All right. Hey, God bless.
You
Good to see you. I think a professor from California. I've seen his equipment in the past, like a spec monitor. He talks to me about Israel, Judaism, just because I walk around like a religious Jew. So here's more sensors, a speaker, and I was trying to remember like exactly that guy's equipment. I've read through his books and looked at his equipment. Some sort of chemical spectroscopy, like you feed a material in, it does some sort of like mass spectroscopy for material science, and he's got his own patent, his own machine, and that's an example of one man with just one machine that he comes to these trying to sell that are useful to the related field of material sciences, a specific machine testing chamber, as opposed to a lot of these companies that might have thousands and thousands of machines. So, this man's been at that conference every year, and he has an interest in Israel. We've talked in the past, and I think I'm connected with LinkedIn. So here we're approaching some of the actual testing chambers and saying some of these ones will actually be extremely big. So this one's made in India, CME, smaller ones. You put materials in, and you can produce extreme heat or cold or wind or vibrations. And they actually make some of these testing chambers that are extremely large, that are the size of buildings that you could put full automobiles in and get to like negative 40 degrees. You could have artificial snow, hail, these conditions produced by machines. Here you see big demonstrations of this one actually has a test in progress. It's like a wind chambers or various things. You said I have the booklets from previous years. Hey, God bless. Oh no, thank you. Yeah, God bless. I have some of these from previous years, and I usually try to do some preparation. So the Automotive Testing Expo itself that travels around the world sends out a book, like a 200-page book, a magazine, like a few times a year. So at least I read through that, but I didn't have enough time to prepare for this conference. And multi-physics platforms, they're very interesting. So yeah, I see reading materials, kind of want to grab it, but I'm going to do the complete tour of the floor. Yeah, I got 8 people watching. Can't really see the chat because it's too much of a strain in my eyes. One thing, the chat only stays for a very brief amount of time, and then the second thing is it's just small and I have to stare at my screen. So I do this largely for myself. So let's look at some of these automobiles on display. Here you got CSM. So as I never heard of CSM. ATI, I know because they come to a lot of these measure calibration, and the huge company that makes all different types of parts. So they have a Rockstar. I never even heard of this type of Jeep, on display to show how their various equipment might feed in tests and sensors. They have an automobile on display, kind of cool off-road automobile. All the various sensors that would go in it and be fed into a machine, computerization. There's the Hummer. I know. So tracks and more testing. So you're going to see what's going on here. These engineers and various sensors put into the engine, and the computer out there and be moving. So you could have off-road or extreme testing. But so a lot of these D-Space, they make very good reading material. I'll come back and definitely want to grab their material. So logistics, infrastructure for this made on gyrators, magnets, shaking. I wish I had more time to read up and all this stuff does, but chess player I know from the area. He's a salesman for these gyrators made on from a Japanese company. and use the Automotive Testing Expo is in a few different places around the world, and based on automobile production. So like Germany, Detroit, Korea, maybe China. So it's changed over time, the type of places that host it. But for North America, Detroit is still probably the biggest center for automotive parts. So even though plants are spread out all over North America, Ohio, and for certain testing equipment or sales. So if you wanted to make a convention to best and past display, environmental testing, drive systems. Here's sound. I've shown these in the past. Extreme sound sensing, computer vibration programs. Some of these companies make parts, some of them computer programming and processing, and the feed mechanisms. My background is in physics, but I'm not an electrical engineer, so this isn't my specialty. Like, I'm not an automotive engineer, and a lot of this tends more towards electrical engineering, which isn't my specialty. But I just figured I'll put on display some of these stuff. Here's just a example of all the testing that might go into a tire. Various things connected, and it could be spinning at high speeds, and these type things that will be used for safety standards. And here's a mobility center, racetracks. I guess this is a design proving ground company that specializes in making proving grounds. So there's probably hundreds of proving grounds all over the world. A lot of larger companies have their own proving grounds, or there's separate companies that just make a proving ground and then will rent out the space, or they rent out the space or test things for various people. And that could be to make one in Detroit because it's local, or it could be more set up in an environmental way where it's in a very cold or warm or high altitude place related to the specific testing, or a conglomeration like they have here in Detroit between various companies that come together to have a lot of the technology testing together. And so any of these companies that makes millions and millions of cars, you'll have a substantial investment in making sure it works, and not just for the governmental standards of safety. Most of these companies go well beyond governmental safety standards. They're worried about making a product that's going to work and last. So I was mentioning when I started this video, impact tests that let me grab a little of my coffee. Automotive manufacturer makes up the biggest sector of all manufacture, and automobiles basically incorporate all aspects of technology and industrialization into it, because the automobile is a huge thing. Automobile has living features of comfortability, seats, computers, and internal computers, sensors, mobility. So almost all forms of modern technology, if they could be incorporated into the automobile, will be incorporated into the automobile, just because they make so much of them, and it's a huge expense. Like your house or something. I guess example of this is a Mustang or something. A chamber could turn the wheels or vibrate. I'm not exactly sure, for just the display. And we got a Pontiac Solstice. So any one of any new technology, if it's 5G, if it's a material science, if it's a computer, if it's a control system, likely will very quickly be incorporated into the automobile for pure economic reasons, that the money to be made from the automobile industry is the largest. So any form of your technology, if you're looking for sales to make it applicable to the automotive industry, is one of your key factors to do. So all these various companies that are coming here, largely trying to sell their products, but saying if you have a new technology, a new idea, a new material, and you can make it applicable to the automobile, that's what you need to do in order to increase your sales, because automobile is the largest manufacturer, and that means that basically all forms of new technology and ideas quickly get incorporated into the automobile, because it's almost everything is applicable to the automobile, and whoever figures out how to do that will, at least for a period of time, have quite a economic advantage over other places. Okay, so just look at a lot of this reading material. I'm going to come back and grab. So, as I said, this isn't my expertise, this field, automotive engineering, but, here in Metro Detroit, I'm more in construction, background in physics. You could have, look at all these electronic devices, and also you see like the rise of China. So that's some like batteries, where I mentioned at the battery show, if anyone saw that, my last Ramble last month, is becoming more and more Asian. So automotive testing is also becoming more and more Asian, but at a smaller pace. So you have a bigger contingency of people from Europe, mostly German, German manufacturing. But there's a international contingency, and I didn't do enough book research to look through the reading material to see who's going to be here, where all the companies are, the breakdown. But I mean, they don't have the German embassy here. Like by the battery show, they even had enough German companies that the embassy itself will show up, or they had from various things. These ones are really cool. I've shown them in the past. These are directional sound testing. They have these like special devices that will record where sound is coming from, which is very important for cars, because vibration or sound protection, how much sound comes from the outside. So they have these directional monitoring devices that will tell you exactly the direction and the values, and break the sound waves into like a digital footprint of where all the sound is coming from. And so that's another aspect of the automobile's sound mirror on the inside. The automobile's pretty loud. We got a McLaren here. So automobile's a pretty loud machine, but you're on the inside, so for driver comfort or even safety of possible damage, a certain decibel level could damage a person's ear. So sound test, these displays, you look kind of cool. You could see these things where you really wouldn't see them anywhere other than something like this. You just like, yeah, that'd be kind of cool. Although, that might cost thousands or tens of thousands of dollars, these kind of like sensors. And architecturally, as a civil engineer, I could possibly see some sort of use, to putting a sensor like that, a sound test sensor, maybe for acoustics, if you're in theaters or stadiums or music performance, that some of these devices are pretty cool. Like, okay, I'm a streamer in cameras, so they have special cameras for industrial uses that are actually much better than a lot of cameras that exist for entertainment type uses. And the companies here that use them, the precision necessary when you're building automobile that needs to be safe for use to the average consumer and to be used for years, that they have these special cameras that could literally do like millions or even billions of frames per second. And then the computer technology to do all that, versus like a streaming like that 1080 HD I'm probably not even going to get 1080 HD, but if this video is at least 720, um, yeah, Andrew Yang, HT, talking about the General Motors strike still going on. Andrew Yang says it's more based on automation than management greedily taking a lot of money, historical debates. I mean, management, even if all the money that management is taking is distributed to the workers. So here's an example of high-speed cameras on display. They only have a few on display, but NAC, image technology, um, pressure gauges, pumps, various engineering. This might be a IT for proving grounds. So like the sensors and feeding it into computer and having a central computerized system. I've read their material in past years. So it's pretty interesting. Like the proving grounds are pretty interesting. And I guess we actually have a talk. So this guy's got water to give away in their chilling testing chamber. So you'll have industry experts come in and talk about some of their most recent findings. So I wanted to come by and support engineering in Detroit. This is one of the more important shows. It's not that interesting, automotive testing. You make America, make Detroit great again. So definitely want to support Detroit and these conferences being in this area. But automotive engineering is not super interesting. Here's another one, Photron high-speed cameras. So some of these could get millions of frames per second and extremely high quality cameras that probably better than even you'd find for entertainment purposes, maybe much more expensive. Crash test dummies. I get the books, various companies that make crash test dummies, various companies and facilities that simulate crashes, and that's a necessary part for automobiles. Said millions of people, billions of people drive. It's proving ground. But so many people drive that there's so many accidents and so many deaths, and saying like relatively, death by car accident is one of the bigger causes of death, probably even more than like murder or gun death or something like that. That car accidents, because everybody, even substantially below average intelligence, could get behind the wheel, could drive, even though they aim to make cars more expensive, and the newer, better technology cars are more expensive and higher technology. You get cheap automobile cars, so the tens of millions of people across the United States that have. So here's one of these sound cameras. You can see me there in the background. In that the even color on the screen coming from me talking straight into this reading the sensor. So there's going to be a certain number of crashes. There's nothing you could do to prevent automobile crashes, and so the companies will have thoroughly tested what happens when there's a crash. How do they limit damages? How could they limit harm? And the cost-benefit trade-off. Say, okay, you can have certain people are going to die, people are going to get injured, and maybe you could pay more money to make safer cars, but that might make it more prohibitively expensive to make car ownership readily available. So, you have the regulation, like minimum standards that the government might require people to make versus industry standards and, name brands. It's like, BMW or Mercedes that here, largely produce luxury objects, but like in other countries might produce utility cheaper cars. And, so their reputation and branding will also be a factor in how they, how much they put into the care of, say, okay, people are going to get killed and or injured in accidents, and it's going to hurt the branding versus, prohibitive prices or making a utility car. So you have like Tata automobile made in India. Cheaper cars on the American market. New car you're looking usually like at least $15,000. Although, like in other countries where they don't have the same minimum standards, you might be looking at cars for as cheap as $6,000. And if you watch like those things like Live Leak or something like that, or Best Gore, you could see some serious damage from automobile accidents around the world. A lot of them like India or other countries that might have cheaper or less regulation standards, and saying everyone wants an automobile and to take advantage of it. And if you increase the technological requirements, making the cost prohibitive to get an automobile. So the amount of testing that a person does in their automobile, the amount of standards that a person wants to have in place in order to be able to sell their product, or at a societal level, should everybody be able to drive, even versus environmental, or maybe the mobility. You talk about driverless cars in the future where people won't own their own cars. You'll pay per service, and there'll be companies that have the car and then just want to go. What's the advantage? If it's a driverless car, doesn't matter if all the cars are in like a lot a few miles away and come to get you, or if the car's in your driveway. And so it's interesting things. And I had streamed a public study session on the implementation in the future of some of this equipment. Yeah, vacuum equipment. Lord, big companies. So I'm almost done walking around with this. I got you can see I'm 80% done, so I'm gonna finish the walking tour of the whole floor, and I'm gonna go and gather a moderate amount of reading material, because like I could gather tons and tons of reading material. It's very interesting. I like corporate profiles or scientific explanations, but a lot of these are just booklets on very specific amounts of machines, or if they're big companies, they make whole series of machines. They have corporate overviews of the various products, and it's overwhelming. I showed in my library, toured my library, all of the books I've acquired and flipped through and read in the past, and even the ones that I've, the last few years, I still haven't had a chance to flip through. So, I do see all this reading material, and it makes it interesting to me, because that looks like a Porsche. So we got intelligence, metrology, sensors. So this company, I guess, making sensors and metrology, but they have a Porsche set up here for viewing that would be able to various things like, okay, how does the door close? How tightly do the various moving parts come into? How much sound? And I said that an automobile could largely be basically completely reduced to a series of differential equations. That all the aspects of the engineering in an automobile could be reduced to the component mathematical equations of the various physics, like COMSO, we'll call it multi-physics, where you might have combustion, thermodynamics, material science, stress and strain, electrical engineering, energy production, various aspects of a car that you put them all together, and you could look at all the various mathematical, physical laws that are going through the automobile when it happens. That some of these companies have basically completely reduced the automobile to a series of mathematical equations, and some of the environment, the conditions that they drive in. So there's a lot of unknowns. So you could have predictions relatively of what average driving conditions are, like all the proving grounds and the various things. And it said entropy is a mathematical law. So it's not just like entropy, like everything goes to crap eventually. Entropy has exact mathematical connotations within the material physical sciences, where you could know the effect of entropy and make exact calculations for how long it'll take entropy to have its effect, and the lifetime of a various product. So it's not just like you have entropy and said that everything goes to crap eventually, but there's exact formulas, and you could have a prediction model for how long it's likely to take the entropy to wear down on a given system. And so that could largely be reduced to a series of differential equations and tested. And then cars used to be standard. I have a Yoram Haran, a professor at University of Michigan. I read his book, and he called it a reconfigurable manufacturing processes. So when Henry Ford had the Fordism and the original manufacturer, the idea was to make every car the exact same. You'd have the exact same production line, and then at the end, like the Model T or something come out, and they'd work out to be the exact same. And for decades, that was the model of cars. You had a certain model car, you might have like a few color options, or you could pay more for like a stereo or a few different models, but there were very few options. And now they have reconfigurable manufacturers, became more applicable and cheap, and therefore you have more variety within your type of car. So it's not like popular like Lexus, or I got a Jeep or something that may sell millions of models, and they might be relatively the same, like 98% the same, and then a few variants in like what type of speaker or air conditioning or the minor options that you have available. And other more expensive cars might have more options available in terms like the materials and various factors that go into it. But so to have like an exact formulaic, where a car is the exact same, it's a nice sensor board. Okay, hi T. Do I work? I run an eBay business, and I do some property management. I'm an engineer. Like I'd like to make profit off of this, like as a consultant, cost estimator, scheduler. Because a lot of this equipment is extremely expensive, and it's made around the world. So let's say some of these testing chambers. So I don't do it like in terms of consultancy or sales. I'd consider becoming a salesperson for 3D sensors and printers. But I didn't go through the training. I'd have to have a company that I was selling for, and some of them cost tens, hundreds of thousands of dollars, like good 3D printers, like let's say metal filament printers that are still hundreds of thousands of dollars. And it's conceivable that there's thousands of places across Michigan that would be interested in these. So you'd have to network, find the available networking events to meet the people, go out to the facilities, be an expert in it, have negotiated deals where like how much commission or price or intermediary. So I'm not currently doing any of that, although it is conceivable in the near future. So your LED lighting, just for headlights, or even testing of lighting, effect of light on wear and tear of a car. So I'm almost done, but so I mean it's possible to make substantial amounts of money off of this as a equipment dealer or supplier or consultant, or for construction here in Michigan, which was originally my field. Why I came to look at this stuff was because I'm in construction management, and a lot of the biggest construction projects in this area are for manufacturing facilities. But I haven't been able to find direct employment from any of this. It's very complicated. And so I'm starting to do these streams. I know more and more people. The first years when I came here, like, who are all these people? What are all these companies? What do they do? And, now, so I know these companies. I know the supply chains, and I actually have international contacts where I've been coming to enough of these that people who come to the show recognize me or even expect to see me. Although I'm not buying or selling like the Kabad song, Johnny Johnny, what do you do in the marketplace? You don't buy, you don't sell, all you do is cause trouble. So you don't want that to apply to me. I'm not a troublemaker. I'm a scientist. I'm an academic. I'm promoting this area. But as of now, like I'm not buying or selling anything. And you got Siemens. You go to the Siemens conference every year. And hey, how about a great day? Finishing up the tour. And so just got a few more aisles, then I'm going to end the stream. So if anyone had a chat, a question, or something that they really wanted me to go and film, maybe ask for a demonstration. So I do this for my own purposes. So you say this is more internal, where the battery show, you have to be pretty into technology or the automotive industry to look into testing automotive parts. So you're saying, you have a few suppliers that come to these and figure, okay, like I'll set up a table and try to sell my stuff, or a lot of the bigger companies that just have tables and send people to all of these shows. So this is a pretty niche show, relating to testing equipment. I think next week they have automotive interiors, and I might come down to that just to see all the scientists or the companies. But how interesting it to walk around and see all these people displaying. As a physicist, automotive testing is more interesting than say something like the interiors, because this mostly based on physics, everything that's going on. Saying reducing the car mathematically, recording sensors, monitoring everything, and being able to make accurate predictions, models for how well a car is likely to last, how long it's likely to last, what's the best way to make and produce it. So this one's more interesting, as a physicist. Okay, let's get a speaker, little model here. Detroit Open House, 1024. So it's a company here in Detroit that has an open house. So I'm going to walk back to the other corner, so I might chat a little bit. I played a whole bunch of chess over the Jewish holiday. When I get back to work, like as said, you could make large amounts of money. Like people who are in industrial equipment sales, because the equipment's very complicated and it's very expensive, and there's relatively niche to like I have books, and you get like a yellow pages that will show you the thousands of various companies that manufacture stuff, and to know the latest equipment, to have a deal worked out with one of the suppliers. And most of these places, you walk around to the different tables and actually speak to the people, and they have like regional salespeople. And I've met people in the area, that there's tens of thousands of people. That's what they do. That's how they make their living. They're a regional salesperson or tech support for these various companies that, they make money by selling their products. So, it's saying they just want to make a sale possibly, but looking how does it integrate, from the scientific level to what's the newest technology, how does it fit into your manufacturing process, what's the cost level and price point to adapt, and just if you're making a widget and it needs to meet like ISO standards or something, you have to meet the various standards and conduct a certain amount of testing. So working out a deal where either you're sending it to another place to be tested, or you're conducting the testing on site, and you need to purchase this various equipment. And as I said, these standards change relatively quickly. That every few years the standards bodies might change their regulation of what needs to be done. Technology change, you have better materials. As I mentioned multiple times in the stream, basically all science and latest ideas gets incorporated into the automobile. So any new interesting scientific idea then there's the question, well, how does that affect the automobile? How does that, if it's in terms of a manufacturing process, or how does it affect how parts are made or global supply chains? To can you add that new idea into the automobile? If it's just in terms of like Siri or Skype or phone, can you stream, like instead of connecting your cell phone and streaming from your phone, can you have YouTube and a camera, and to be able to do that straight from your car? All the various things that are now part of the automobile, like the automobile is basically a computer. It's basically a home system, a maintenance system, other various things. So that's constantly changing. As there's new technology, new ideas, uh, how will that incorporate into the automotive industry, which is one of the biggest, if not the biggest, industries in the whole world. Maybe the oil industry or something is related to the automobile industry. So, so to stay on top of the science, know the direction of technology. And I don't really like sales, so most of this, if you're academic, you could be like a university or part of research and development. So I'm just kind of Duvid's independent science geek. I like technology. I like engineering. I like understanding how things are made. But like money's good. You're like, okay, it's a mitzvah. It's not a mitzvah to be poor. And if you could make that money, there's many ways to do it. And but you could see like batteries are a newer business. There's more economic opportunity. It might have easier, lower barriers to entry, as opposed to something like automotive testing. It's more intellectually demanding, just to understand the logistics of how the automobile is made. How does an automobile work? Like people drive an automobile, and maybe you have to have your brakes replaced, your oil changes and things like brakes and tires need replacing, or God forbid, like transmission or engine problems, or if you drive a car till it dies, to what caused it to die, or just maintaining your automobile versus understanding how does the automobile really work, combustion, thermodynamics, the energy density, you have all the battery, all the various components, and it's pretty complicated. It's like to reduce the automobile to a series of differential equations, even just to a cursory, simple, non-scientific, simple explanation of all the various parts that are necessary to make your automobile work. So that's a complete floor tour. I'm back at the beginning, back by some of the interior section, and I'm gonna maybe speak to some people, gather some reading material. So thanks for tuning in, for watching. I got more people now than I had on all day. So even like quantum computing, like if they did have quantum computers or something like that, then the question, like, will you eventually have a quantum computer in your car or something like that? And there could be things like vibrational, things where, even speakers or anything that operates in a home system is usually more complicated to operate in your car because of all the vibration and wear and tear associated with having something in a moving object as opposed to a stationary object. Yeah, I mean, anything, even so, if quantum computers get made and they become economical, and they're not limited by like the vibration or whatever from a car, like eventually you have quantum computers in your car also. Okay, so yeah, the interior is not that interesting to me. Like, I mean, material science is interesting. As the automotive interior convention, I'm probably not going to go to them. It's interesting, look at all these companies. They're making various components that go into cars. And hey, God bless, great day. Yeah, it's very, very interesting, but I don't have enough of expertise. I have these, magazine, Automotive Interior World, and they even have a magazine, Veganism. Okay, so I wasn't going to take this, but I see they have an article about veganism, I guess probably on leather, the various seats, do you want leather in your cars or not? So, I'd walk through here, vertical integration, manufacturing, Edison, Litech, lighting. Grab this. Let me grab your company profile.
Yeah, sure
Okay, so I'm going to start grabbing reading material, and it's going to be too complicated for me to continue the stream. Although I think appreciate people tuning in. We'll see what happens. The future streaming. I'm not exactly sure what streams I got planning coming up as of now. So signing off. Hope people enjoyed. If you're in the Michigan area, come check out this show, and I should be back to doing the week in review with Church of Entropy Sundays. Now that the Jewish holidays are over, maybe I'll do an occasional chess stream or something. So take care, everybody. God bless. Have a great